Okay, in this video, I'm actually going to do kind of the pickup section. So this will contain talk about inverses, real short, because there's another way to compute inverses rather than the way I'm going to teach here, and then kind of some ideas about derivatives of matrices and integrals of matrices. And I'll actually start with derivatives and integrals because they actually operate the way you would hope they would. So if I took the derivative of a matrix A with respect to, let's just say t, because that's generally the variable that we're taking with the derivative with respect to, it ends up being that you take that derivative to the interior of the matrix and take the derivative of each element. So that would be the derivative with respect to t of each element within A. Okay. So a real quick example, you might have a matrix that is, let's say, 1x negative e to the x and sine of x, right? So if that's A, then this implies that the derivative of the matrix A with respect to, x, sorry, I used x's there, so I'll have to use x's here, is going to equal 0, 1, negative e to the x, and cosine of x. Because those are the derivatives of its internal elements. Integration works the same way. So if you wanted to integrate the matrix A with respect to t, one thing that you will have to note here is that we have to state that A is a function of t. It has to be a function of a single variable t. And technically it doesn't have to, but we're going to assume that. Also, you don't want to have a bunch of plus c's everywhere. So usually when you're integrating a matrix, it's from a definite, it's over a definite interval. So from x naught to some x value. Okay. And if that's the case, anyway, you just integrate each element over that same interval. So dt is what I'm using, so I'll use that. All right, so derivatives and integrals are just element by element, not terribly difficult. Now let's actually talk about the inverse. There are several ways to compute the inverse of a matrix. And if you read the textbook, the author has a kind of an old school way of doing it. However, it can be fast at times. So that when I say the inverse, by the way, I'm talking about this a to the negative 1. Remember, we had the multiplicative inverse property where a times a to the negative 1 is equal to I. Again, where a is n by n. It's a square matrix. So if you want to find out what a inverse is, which is incredibly important, actually, that's what we generally do, there's a couple things you need to know. First of all, we need to talk about a transpose, and I'm kind of running through this really quickly because I have a class in a few minutes, but you need to know what a transpose is. So a transpose basically just takes all the rows and makes them into the columns. That is, if I told you that A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, that would imply that A, and then we're going to do the transpose, so the capital T as what you would think is an exponent. It's not an exponent, but it's in the exponent position, means A transpose. And all you're going to do is take that first row and turn it into the first column. And you're going to take the second row and turn it into the second column. And take the third row and do the same thing, third column, right? Or sorry, I'm saying that backwards, aren't I? You take the first column, turn it into the first row. Take the second column, turn it into the second row. Take the third column and turn it into the third row. Sorry about that. So here you have that. That's the transpose is actually useful in image processing, but it's also useful in other things as well. So, and specifically when you want to calculate the inverse of a matrix, it turns out that A inverse is going to be 1 over the determinant of A times a matrix transpose. Now that matrix is, if you look in the textbook, it's a little bit archaic how it's kind of written. They call it capital Cij. I would rather describe capital Cij as, well, I would actually rather just kind of show you. These are easier seen than or easier done than actually written out. And these are called the cofactors or the signed minors, whatever you want to call them. But again, like I said, it's easier to see an example. So let's do an example. Actually, let me scroll up because I think we worked with an example before. Yeah. So we're going to steal this matrix here. We're going to steal that and talk about that one. So we'll do A, which is 2, 6, 1, 1, 2, negative 1. Actually, I'll just write that down. So I've written in here, and I know to find A inverse, I'm going to have to figure out what the determinant of this matrix A is, but we actually did in a previous video. So I'm going to scroll up. And there's the matrix A, and the determinant was negative 11. So I'll go ahead and take that negative 11. I'll put it in the denominator here. So A inverse is 1 over a negative 11 times a matrix transpose. And so let's go ahead and figure out what I mean by a matrix transpose, because that is going to be a very, well, it's going to be a little bit of work. Not a ton, but a little bit of work. The way I'm going to do it is this is how I always did it when I was a student. I'll put a little transpose sign right there because I'm doing a little work first. And so the first element, and I'm going to go ahead and put a little box here. And that first element, I am going to, again, put these signs here, plus, minus, but I'm going to do it throughout. Plus, minus, let's see, put all this stuff on here. There we go. And what I'm going to do for that first element is I'm going to cross out in that matrix the first row and the first column. And I'm going to take the determinant of what's left over. So because it was positive, so notice that this is positive here. Because it's positive, I'm going to have a positive. Let me write this in here. Actually, let me go ahead and I'll call this C11 and C12 and C13 and C21 and C22 and C23, C31, C32, and C33. C11 is equal to a positive, again, times the determinant of what was left over. So 2, negative 1, 7, negative 4. So this is like finding the determinant. And just to illustrate it even further, okay, that was supposed to be a plus there. My eraser's kind of big here. C12, I'm going to run it. Actually, I can just scroll over to the right here. C12 is going to equal, well, let's see. What happens when we cross out the first row and the second column? So here I go. I'm going to cross out the entire first row and the entire second column. Remember, there's a minus sign there. So what I'm going to do here is I'm going to start this off and I'm going to say it's a minus and then the determinant of 1, negative 1, 5, negative 4. Oh, you can't see that. I'm so sorry. So because I crossed out the first column or first row and the second column, and because of that negative sign right there, what I did was I said C sub 1, 2 is going to be a negative, and then what's the determinant of what's left over, which is the 1, negative 1, 5, negative 4. 1, negative 1, 5, negative 4. And so on and so forth. So if you're going to play along for this entire one, let's go ahead and just go through and do this. And you can pause the video to kind of verify my numbers as I go through. So what I'm going to do, I generally, when I was a student, I would just use my fingers to cover things up. So I'll probably use a highlighter here. So first row, first column. It's going to be a positive, and then, let's see, negative 8 minus a negative 7, or a negative 8 plus 7, which is a negative 1. So a positive negative 1. Great. Now I'm going to go to the first row, second column. I don't know why I erased that first row. I could have kept it there. First row, second column. It's going to be a negative, so let me go ahead and write the minus sign in there just so I don't forget. And now it's going to be 1 times a negative 4, which is negative 4, minus a negative 5, which is a positive 1, right? Negative 4 plus 5 is a positive 1. So positive 1 times a negative. There we go. And now I'm going to go ahead and focus on removing the third column. First row. That plus, I'm going to go ahead and write in. And I have a 7 minus 10, so it's a positive 7 times minus a 10, or a positive negative 3, or in other words, a negative 3. And now I move on to the second row. I'm just going to go ahead and cross out that entire second row. First column. All right. And now remember, I'm in the second row. First column, that second row has a negative sign in it, so I'm going to write negative first. And then let's see, a negative 24 and minus another 7. So negative 24 and minus another 7. That's a negative 31. And now I'll go ahead and cross out the second column. Remember, the second column has that plus sign up on top of it, so I'm going to write a plus here. Oops, you're probably yelling at me. When I did that first column, you might or might not be yelling at me. When I did that first column, it was supposed to be a minus, right? Which I wrote in there. But then I said a negative 24 minus 7 is a negative 31. So it should have been minus a negative 31, or in other words, a positive 31. So let me write that in there. Second row, we have a plus, and then we'll have a negative 8 minus 5, which is a negative 13. So I can see that this is going to be a negative 13. And now I go ahead and erase that off and put on the third column. Take off the third column. There's a minus on top of that, so I'll put a minus here. And let's see, we get a 14 minus 30. 14 minus 30 is a negative 16, so we have minus a negative 16, which is a positive 16. And then we move on to the third row. Let's go ahead and do that. First column. First column is going to have a positive associated with it. And let's see, that's going to be a negative 6 minus another 2 is a negative 8. So it's going to be a negative 8 here. Okay. Now I move to the second column. Okay, and notice in the second column but the third row there's a minus sign associated. So I'm going to write the minus sign in. And let's see, I have a negative 2 minus another 1. So it's a negative 3. Minus a negative 3. Which is going to be a positive 3. And finally, barring any mistakes, we go third row, third column. There's a positive associated with this element, so I'll put a positive here for the moment. Excuse me. And I have 4 minus 6, or negative 2. So positive negative 2 is a negative 2. So now we're going to take the transpose of that. So negative 1/11 times the matrix. So the first column becomes the first row, negative 1, 31, negative 8. The second column becomes the second row, negative 1, negative 13, and a 3. And the third column becomes the third row, negative 3, 16, and negative 2. So therefore, the inverse matrix for A is going to be a positive 1/11, a negative 31/11, a positive 8/11, a positive 1/11, a positive 13/11, a negative 3/11, a positive 3/11, a negative 16/11, and a positive 2/11. That is, when I multiply this matrix A inverse by the matrix A, I will get the identity matrix, a matrix full of ones down the main diagonal and zeros everywhere else. You can verify this if you so choose, if you so desire. I am rushed for class, so I'm going to not do it now. But you can multiply those together to verify.